All right. Class on February 13th, take 2. All right. What we have here is our Lewis dot diagram. I gave examples of different compounds, some of the most popular ones like water, and then we showed our Lewis dot diagrams of what each of these look like. And we circled whenever we determined that we had a perfect set of 8 valence electrons. So with H2O, we got it with the 6 valence electrons of oxygen and the 1 each of the 2 hydrogens. And then we did it again with NH3, CH4, and CF4 was really special because instead of hydrogen just giving up 1 valence electron, you had fluorine that actually took 1 valence electron each from carbon. And in this way, instead of just one octet grouping, we ended up with 4 octet groupings. All right? And you guys did really well with getting that, so bravo. All right, we also determined that when you do that, it takes carbon and brings it down to having a stable set of 2 valence electrons, just like helium. And helium is a noble gas. That's why this is allowed. That's why we are allowed to have this right here. So you did great with that. Does everybody have this written down?
Yes, sir.
If you don't have it written down, you can review it later and get the information you need. Sarah, can you hand me that?
No. No. I'm just kidding you.
Okay, now, to kind of get an idea of what we're looking at here, we're going to do a comparison between a Lewis dot diagram, what the structure actually looks like, what the geometry looks like, and then what the angle measurement is for it. So let's look at HBr. And then we've got our Lewis. It starts with a W for some reason. I don't know why it starts with a W.
I thought you said HBO. And that's a GB.
Lewis.
You know you're going to be on
The structure of it.
What's the clock exhibition? I wonder if they got it from that.
We're going to be on YouTube, y'all.
Geometric shape. Geometric shape. And bond angle. Okay, now if we are following along at home, hydrogen has how many valence electrons? How many valence electrons does hydrogen have? 1, yeah. That's not a hard thing to figure out there, guys. What about bromine? Br.
That's 4. No, that's 2. No, that's
I'll give you a hint. It's a gas. Bromine.
7.
And it's 7. Okay, so we'll do a Br right here. That's 1, 2, 3, 4, 5, 6, and 7. All right. Do we have an octet
Yes.
showing? Yeah, we do.
We are stable.
We are stable, which is impressive because how often is this class stable?
Never.
Not very often. All right, now the structure of HBr looks like this.
True.
We've got our H as a single bond right here, and then our Br.
Together.
That's right. And that is the structure. Now, what kind of structure do you see right here? If we were talking about, it's a linear. Very good. Wow. You guys are on fire today.
We're going to be on YouTube.
Yes, I am. Yes, we are.
Linear. All right, and then the bond angle measurement, do you remember?
180
180 what?
degrees.
180 degrees. Good Lord, you are on fire today. Love it. perfect. I know. I don't know if that's the anticipation of possibly seeing that video online or not.
Actually, no, I never watched the video online.
Now, I know that this doesn't have anything to do with the lesson, but it was just asked to me, did anybody ever tell you, Mr. Knight, that you're a nerd? Yes, I've been told this for most of my life. In elementary school, I was just weird. Middle school, I started to link between weird and nerd, and now I'm full nerd. So after the molting stage, everything worked out. So
You're still recording.
I know. Well, just in case anybody's confused, I am 100% nerd. Now, SF6.
Nice one, Mr.
Well, I don't think it's inappropriate to hide who I really am. You know?
You shouldn't lie about who you really are.
Sulfur, how many valence electrons does it have?
Sulfur has.
I didn't think it was that way.
6.
Okay, and are we going to put the S in the middle?
Yes.
Yeah.
Okay. Well, a good indication of where you're going to put your anchor elements is how many you have. If you have one of them and you have a whole bunch of something else with it, then
Okay.
the S is going to be in the
The
middle.
F is the F is
And how many does S have?
7. So it only needs
Sulfur has how many?
7.
Are you sure?
Yeah, because it's in
Oh
group 17.
no. 16.
He says it's in group 16.
It is.
Oh, whoops, I said 6. I'm sorry.
Okay. All right. As long as we're on the same page now. Now, we've got
It's 16
1,
dot.
2, 3, 4, 5, and 6. Now,
You put 6. It's so
she doesn't think it's going to work.
It's not, because you can't add another 6, because if you add another 6, that would be 12, and that's
Okay, but how many fluorines do we have?
6.
it says 6.
So, what could a fluorine do to that sulfur?
Knock it.
What do you mean, knock it.
Back.
Plus 6.
What can the fluorine do
Take
to
it away.
can take away one of those valence electrons? And how many valence electrons does sulfur have?
16.
It has 6. And how many fluorines want to take it away?
6 minus
So how many valence electrons is sulfur going to have when fluorine's done with it?
0.
None.
Well, it's not going to have any valence electrons of this level. It'll drop down to the next one, and that level is stable. All right. So
2.
it may be 2. We'd have to look and check, but I'm pretty certain, without a shadow of doubt, that it's going to be stable. So let's do our fluorine. We're going to do an F here, an F here, 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 and then here. That just looks weird. All right. And I got to do a little surgery there. All right. F here. All right. Now, you and I both know that there are going to be a whole lot of X's here. So if you'll just give me a second, it's going to get messy.
Harry.
But let's be knowledgeable that we have 1, 2, 3, 4, 5, 6 F's, and each fluorine has how many valence electrons?
1.
7.
It has 7 valence electrons. It's in group 17 on your periodic table. And that means that it only needs 1 of each of these to make it stable. So how many octets are we going to have when we're done? Are we going to have 1 or are we going to have 6?
6.
We're going to have 6, it looks like. So let's go ahead and do that real quick. 1, 2,
How is that thing moving when the remote isn't anywhere near you? It's in his pocket. Oh, then. Ain't it? I know. Look at all those X's.
Yeah, I'm not a big fan of X's.
Okay, yeah, we've read a whole novel on our X's. So anyway, let's go ahead and isolate our octet groups that we have here. Right, we've got our 6 here, 7, 8. So that's an octet right there. 6, 7, 8. Another one right here.
They're all going to be
here.
circled.
Here. Here. And then here.
Exactly what I'm thinking.
And then we've got the S in the middle. So not too terrible. All right. Now, the structure of this one is it's a lot different. A lot more different. It is different. Right? So we've got our S here. How many, no, that's right. Everything's accounted for. So we've got F, 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 1, 2, 3, 4, 5, 6. Just like that.
That ain't linear.
No, it's not. It's not. In fact, it's not even a tetra. It's an octahedral. Octahedral.
I said, what did I say?
Octahedral.
I thought I said
And the way it looks, I can do a 4D one. It looks kind of like this right here. We've got 1, 2, 3, 4, 5, 6 here.
Wasn't the degrees for
Imagine it in a 3-dimensional design.
like the marshmallow
So,
thingy?
like an XY coordinate and then a Z coordinate that flows through it. It makes it into a 3-dimensional look. All right, and it has degrees. And if you'll look right here, it has a right angle degree here.
90.
So it has a 90-degree angle. That's right. And another 90 on the side. And so this is 90 degrees. Sometimes knowing that it's 90 degrees helps you understand the picture a little bit better. All right. Now, I know I was a little hesitant on homework for tonight. I want you guys to go ahead and give these a try. And the only thing I want for your homework tonight is the Lewis dot diagrams for the following forms. All right. So
Do you have a paper for us? No,
B H3 P F3 H2O, shouldn't be too hard, guys, and then CF4. And I think you've seen all of these except for PF3 and BH3. So when you're done with it, make sure you give yourself plenty of room for your Lewis dot diagram and your structure drawing. I did not give enough room on my chart, so
Is our marshmallow thing on Facebook coming out on YouTube?
not yet, but it will be. All right.
Homework.
Yes, your homework is just this, or just these right here. I think you can handle the structure.
I won't have
So
time.
I want you to do the Lewis dot diagram and the structure diagram for homework tonight.
I won't have time. Let's go to bed.
Don't you think we all want to, Michelle? We all need a nap just to get our facts straight. Or at least to get everybody back on balance.
All right, so Lewis and structure for homework.